phase and a three-phase. In Australia, we focus primarily on two flagship products, which are single phase, but for you to be aware, we also have a three-phase micro, which is the only one available on the marketplace. As I say, we are bankable, which is a key word within AP System. So the company is profitable since 2012, so pretty much since inception, because again, we were founded in 2010. And all our micros are designed for over 25 years lifetime. So reliability is a key word also for us. Proven, we've installed more than 100 plus installation worldwide, more than 1 gigawatt of micros installed as well. Global, as I say, worldwide footprint, and also dedicated. So we don't run the business only from, let's say, the headquarters in China. We have local teams, as I say, in Europe, in Australia, in all the other countries, and we really have everything you need in Australia. You have Frank taking care of the sales and commercial activities, and you have another guy, Huawei, with also the customer support. So we have a local customer support, not available 24/7 because sometimes we need to sleep, but at least you don't have to go through different countries to have your customer support. And as I say, our offering is the widest portfolio you can find in terms of microinverters. So found a few pictograms to summarize. So founded in 2009 in the Silicon Valley, headquartered in China. I already said that, so I'm going to skip it. And because innovation is part of our DNA, we have, as of today, more than 100 patents listed and for the development of our micros. Our solution, so we have a Duo, our flagship product for Australia market, is the Duo, the YC600. It's a single phase microinverters with 2 MPPT. We'll come back in more details later on. Not that one. The QS1, Q is for quad, so it's a 1 micro for 4 modules, 4 MPPT, also single phase microinverter. And coming soon is a QT2. Q is still for quad, T is for 3 phase, and 2 will be the second generation. It's a native 3-phase microinverter, and we're finishing up the development, testing, certification, and should be on the market by end of Q1 2021. As I say, our micros are designed for 25 years. We focus a lot on the reliability testing, long-term testing. All our micros are potted, which guarantees this kind of 25 years reliability lifetime. And as you can see on this picture, we have an approach which is really FPGA, Field Programmable Gate Array. It's mainly software compared to hardware. So when the micros are continuously connected through the internet and through the cloud, we can push software, firmware update, a little bit like an iPhone. If I try a stretch to push firmware update, optimization of the software, and we can really customize the software of the micro so that it can really behave nicely if you guys are in an area where the grid is unstable, where you have surges, where somehow the grid doesn't behave as it's supposed to do. So we can really fine-tune every micro thanks to this technology based on the FPGA circuit. It's really software more than hardware on the way we manage the micro. Sorry. The live testing, this picture is not really interesting, so I skip. So this is our solution. So it's a micro. So for the, here you see the YC600 as an example. So typical residential installation. So 1 micro for 2 panels. With 2 MPPT, so each panel can be optimized individually. And the communication between the panels and the gateway, it's done through Zigbee. So Zigbee, what is Zigbee? It's a industrial Wi-Fi, 2.4 gigahertz, so way more robust than the Wi-Fi that you guys have at home. And so the communication between the micro and the gateway, we call it ECU, Energy Communication Units, is done through the Zigbee signal here. And eventually this gateway is connected to the box or the router at the at the homeowner, and all the data are sent to the cloud, so that the homeowner and also our tech support and you guys, our installer, can monitor easily the installation performance on a daily basis, 24/7, panel per panel. But Frank is going to show that in a few minutes. All right, so that was for the presentation of the company. And this morning I had a surprise. Frank was supposed to guide you through those slides, and he kindly asked me to do it. So please bear with me for a few more slides. So what is a micro compared to a string? So basically, I have my picture here. I try to make it smaller, and then I can see the entire slide. Yes. So you guys might be familiar with string inverters. So the modules are connected in series. And because the modules are connected in series, all the voltage, the VOC voltage adds up. And at the end of the string, you can have up to 600 to 1000 volt DC on the roof, which can be a fire hazard, as you guys know. So that's one of the challenges of the string inverters. Modules build up in a string with high DC voltage, we can be a fire hazard. With a micro, you don't have this issue because the modules are connected in parallel. So basically, at the back of every module with a micro, whether it's because we have again 2 MPPT on our Duo, so you can imagine this is one channel, this is another channel. You have at the back of each module only the VOC voltage, so that will be 40 volts. So it's kind of a in case there is a fire hazard, fire people have to intervene. Is what micro inverters, micro system is called safe to touch. It's already built in. You only have less than 80 volts, so it's what it's called safe to touch compared to a string inverter. Again, go back to the string. So basically, in an array built up with a string, the modules are built up in series. So the performance of a string is dictated by the weakest,
Stefan, we've lost you on audio. Can you hear us?
Let me see.
You're back now. I can hear you now.
I'm back. All right. Okay. Sorry about the, but I don't see the slide anymore. Okay. So I need to share again, apparently. Sorry, guys. All right. I don't know where you guys lost me. Did you lose me?
No, you're only gone for like 30 seconds, mate. You don't have to back up too much.
Okay. All right. So in a string, the module are connected in series, and the performance of a string is dictated with the weakest module. So if you have cloud covering partially some modules, you have broken cell, hotspot, dust. At the end, the performance of the string is dictated by the weakest module. So you will lose some performance. And here the string will be only powered up at 50%. If you go for a microinverters, every module, because we have a MPPT per module, every module is optimized at its peak, regardless is covered by cloud or not covered, an ideal exposition. Then you have a highest yield of for the same number of modules when installing a micro compared to string inverters. And because of this flexibility of the design, you can put modules on the east side and module on the west side, and you will have optimum performance from the east, optimum performance for the west. But on and all, every module will give its best, regardless it's facing east, west, or any situation on a module. So micro operate independently, so then you can circumvent any incident, dust, clouds, hotspots on a module. Monitoring. So Frank will go into detail of the monitoring later on. So it's a monitoring module by module. It's either on a web base or on an app on your phone, and you can really monitor the performance of a micro 24/7, and you can quickly spot whether a module or a micro is performing nicely. We monitor every 5 minutes, or let's say we send a data point every 5 minutes, but the monitoring, it's done constantly between -5 and -10 and -10 and -15. And you can check everything literally.
You got out again there, Stefan. Your mic is out. You're back. Okay.
I'm back. Okay. That's kind of weird. Sorry about that, guys. I have an issue with my mic in the past 3 days, and I don't know how to fix it. So I am screen sharing apparently, so I continue. So the monitoring, you can see every single module, and in terms of maintenance, you can directly zoom in. Oh, this micro has something wrong, and if we need to replace it, then you can directly go into the roof and replace the faulty micro. You don't have to inspect every single module like you would have to do it for a string inverter. All right, so we already discussed that. Quick installation. Frank, you're going to talk about that. So we have an app. It's called the ECU app to install the micro. It's very handy, and you can commission a system in less than 20 minutes thanks to the app. Very handy for installers. Pictures of systems, not really interesting. Our micros. Frank, you have to help me here a little bit. The default warranty, I'm not quite sure about Australia, so the default warranty is 15 years.
The standard warranty is 10 years. We also, offer 5 years warranty extension. So that means the warranty is up to 15 years.
All right, okay. So as a summary, the pictograms, powerful. Our micro can follow up the trend in modules, energy efficiency, reliable, up to 25 years lifetime after testing, guaranteed 15 years. So we have a lot of margin. Modular, so you can put 2 or 3 micro one day, you like it. People have a little bit more cash to invest in solars, and they can have a few other modules, no problem. Safe because of the technology of the micro compared to a string, safe to touch, and really plug and play. It's super easy to install the micro, as I'm going to show you in the next slide. But before, a little bit more details about our flagship product, the YC600. So it's 2 MPPTs, so 2 trackers. You can see here the DC input, module number 1, module number 2, the Zigbee antenna, which is molded. And here the pictures doesn't show, but you have a 30 centimeter AC connectors going out of the micro to plug in the AC signal. So you can put up to modules from 250 watt. It's pretty outdated, but interesting is up to 440 watt. We can only accommodate modules up to 72 cells, 60 and 72 cells. Our input voltage is not wide enough to accommodate 96 cells panels, in case you guys want to ask. And the peak output summary YC600, it's not rocket science. It's 300 watt times 2. It's 600 watt on the AC side. So for a micro, is a bit like a string. You can push up the DC side. People with a string, they oversize the DC by 1.2. It's a little bit the same for a micro, so you can oversize up to 700 watts, 720 watt DC. So ideally 360, 370 watt panels. If you push it, if you push the envelope, the micro will not be damaged. You may have some little bit peak shaving during the sunny hours, but nothing major here. IP67, Zigbee communication for all our micros. It's a single phase micro, but you can build it up in 3 phase and try to balance the 3 phase when you do the layout. A QS1, so that's 4, Q for quad, S for single phase. Also, you can see the 4 pairs here of DC connectors. The Zigbee antenna is on the side, and same story, the AC output is a 30 centimeter AC cable with the female connector going out of the micro. For MPPT, so you can really use every 4 modules connected to QS1 will work independently. You can use modules from different type, different brand, different orientation, east, west, no problem. Same story as for the YC600, only 60 and 72 cells panels. Same wattage for the modules. Again, the basic calculation, 1200 watt AC, ratio of 1.2, so you can push the envelope to 1400 watt on the DC side. And if you push it further, same story, micro will not be damaged. Might be a little bit of peak shaving during the noon times of the summer times. IP67, Zigbee, and it's a single phase, but same story, you can put it in a 3-phase and try to balance the phase when doing the installation. What's missing is that the ECU, energy communication units. So we have 2 ECUs. This cute little box, so it's called ECU R. So the R was at first for residential, but we can also use it for commercial. You have a Wi-Fi antenna, sorry for the French, coming back. So this is for the Wi-Fi connection between the ECU and the router at the customer, and all the data will be sent to the cloud. And one of the antenna is a Zigbee antenna for communication between the ECU and the micros. So very small, very cute. It's even smaller than a router, so it's very elegant. You can put it on the living room at the end user, and the wife is not going to scream because it's horrible in the living room. So monitoring 24/7, module level monitoring, Zigbee communication again between the micro and the ECU, and Wi-Fi or Ethernet cable between the ECU and the router. An ECU under Stamina, the ECU-C. C was originally for commercial, but we can also use it at home. So you see, it's a bit more for commercial because it comes with a DIN rail, so it has to be put on an AC box. And there is more feature on the ECU-C compared to the ECU-R. You have here on the side the SMA connectors. One is for the Wi-Fi antenna, the other one is for the Zigbee antenna, an on-off button. And you have all these little pins on the bottom and on the top of the ECU-C. And basically you have way more function feature on the ECU-C. You can add up some CTs, current transformers, and then you can monitor the production and the consumption in the house for consumption monitoring. I know in Australia, in certain states, you guys need to have a 0 injection to the grid, so the ECU-C can pilot the 0 injection. So as soon as your PV produce more than the load in the household, then the ECU-C will gradually shut down micros by steps of 50 watts to make sure you never inject the excess into the grid. And same as for the ECU-C, ECU-R connection in Zigbee between the micro and internet, Wi-Fi or Ethernet cable here with the router. And the EMA, that's our monitoring platform. So I never remember what it means. I think it's energy monitoring and analytics, module by module, 24/7. So we collect a data point every 5 minutes, which is an average of what happened within minute 0 and 5. And the data are sent to the EMA portal every 15 minutes, but you will have 3 points, 5 minutes, 10 minutes, 15 minutes. And you can see the bell curve growing up nicely during the day. You can monitor from a web base, and you can also monitor from an app, very handy. You can monitor the performance of your system for the end user anytime when you're at home, not at home. And you can see quickly, for instance, this micro slightly producing less at the bottom row, the force from the left, slightly producing less. So maybe it's shaded, maybe it's covered by dust, maybe something else. So this is the CTs I was talking about with the ECU-Cs. So you can see the green curve is the PV production. The blue curve is the consumption in the household with all the electrical appliances. And this one, the gray curve, is what we call imported, exported. So that either you need to pull from the grid because the PV is not producing enough, or if the PV is producing more than you need, the excess is injected to the grid. So on this example, maybe not a good example for Australia, because we should have put an example when you can see that the micro are shutting down, and then there is zero injection into the grid. In some states, I think you guys need to have this feature. So we are everywhere in the world. So you have a few systems, just pictures of more or less beautiful houses with PV panels. I'm not going to spend too much time on it, but you can see the flex of the installation. 2 different arrays, ground mount on the roof, and you can see different orientation. No, not on those pictures. Gas station in New Jersey. So this is more for, let's say, mid-size commercial. It's a 100 kilowatt system, so it's a 3-phase. I know, but you can see here it's a QS1. You recognize a guy with these 4 pairs of DC connectors. Benbridge Island. I skip. Oh, this is nice. What we've done it's camping in Spain. With a lot of bungalows, and every bungalow has 6 or 7 modules. And the advantage of that is that you can monitor everything with the same ECU. We have a function on an ECU which is called ECU share. And as the name suggests, you can share the ECU monitoring feature within the different bungalows. So if you guys have this kind of configuration, you do not have to put an ECU per bungalow, but you can have just one ECU. Well, at least there is more here because the site is very spread out, but you can have one ECU, you share it within 5, 6, 7 bungalows. So also optimizing of the cost and the pricing during the installation. Design and installation practice. You guys are installers, so you will know better than me. So I'm not going to pretend I'm the expert, but it's very easy, especially for the YC600 and QS1. You have the rack, you put your micros at the right location to make sure the micro will be under one module to be covered up. Then you put the bus cable. So basically, I mentioned you have the 2 DC pairs, an AC output, and then you have a bus cable, AC bus cable running along with a drop or connectors every 2 meters or 4 meters to connect, to go and plug in the AC. And one side will go to the junction box and to the AC box at the end. You put the panels, you connect the junction box to the DC input, click, and then you're good to go. And then you connect the DC connectors. QS1 is a quad, same story, except it's with 4 panels. And the good thing is that the QS1 and the YC600 are compatible. So if you have an installation with 10 panels, you can use either 5 YC600 or 2 QS1, 2 quad, 8 panels. And for the remaining 2, use a YC600. And if you have only 9, you can use also YC600 and just put a cap on one of the DC connectors, and you're also good to go. So a lot of flexibilities for the design and the installation. Before you ask, we don't have a single. So here you have a better idea of.
It's your mic again, Stefan. You've gone dark. You've gone quiet, buddy.
I'm sorry.
Back now. Gotcha.
Yeah. Again, sorry about that. Can you still see my screen?
Yes.
Okay, cool. I really need to fix this mic someday. So that's the micros, DC connection, Zigbee antenna, and the AC connector, which doesn't show up on the HD pictures, with a flat female plug, and then you have the AC male side. It's a kind of I don't know to say in English, a guirland. So it's a long cable. You have 2 meters distance between each drop, or sometimes 4. And if you If you don't use one drop, we have a cover too, and then you plug and play. You plug and play the bus cable into the AC connector. So if you have an installation with 5 macro, you will order a AC cable with 5, we call it drops, or AC connectors, with 2 meter spacing or 4 meter spacing, whether you are in portrait or landscape. And you also have all kind of accessories, AC connectors, male, female. So if you have an array on one side of a dormer and an array on the other side, then you can connect both mini systems together. On one hand, you have an end cap to cover up one extremity, and on the other end of the cable, inside you have 3, the phase, the neutral, the ground, and you go to the AC box. And if you use only 1 micro for 1 panels, we have also some connector cap on the DC side to make sure there is no humidity and all kind of dust coming into the DC connectors. So I already mentioned the accessories, which are optional. If you use a 4 meter drops and 2 meter drops on landscape, you can, but this one you can cover it up with a Wycom cap, DC connectors cap here, and the bus cable unlock tool, very handy. It ensures to have a very clean unlocking of the AC connectors. I would not say you could do it with a screwdriver, but the experience proved that if you force it with a screwdriver, you may damage a little bit the pins here. So better to have these tiny unlock tools ready to go. It's kind of a detail. How many panels? Yeah, it's not rocket science. If I have 10 panels in the system, I'll take 5 YC600, a bus cable with 5 drops or 5 connectors. So I skip this slide. Yeah, quantity of panel divided by 2, quantity of micro, unused channel. All right, already, how many faces? So you can only put 7 micros YC600 on a single branch. It's a current limitation for the breaker. You can only put 3 QS1 on a single branch. It's also a current limitation. These kind of things. You can read it on the data sheet. You can, as I say, we have 2 types of ECUs. So if you don't need the fancy measurement of the consumption of the house, no need to do 0 export, you can take just an ECU-R. And if you need something more advanced with consumption, 0 export, then you can go for the ECU-C. And you need to, the ECU-C, the 0 export, you need to measure and the production and the household. So you need what the CT rings or the current transformer. So it's 1 per phase. So single phase, you will need 2, 3 phase, you will need 6. Example. Okay, you can, I'm sure Sean, people will have the slide and they can look at the detail by themselves. Again, schematic of an installation, 2 panels, YC600, the bus cable going to the junction box. And then we have a YouTube video channels where you have more details about the YC600 QS1 installation, the configuration, commissioning of the ECU-R, and site design and installation prep. So feel free at your leisure to go on our YouTube channels and watch the videos. And that's all for me. Thank you guys, and apology for the mic issues.
Now that was all good, mate. Thank you so much for that. Thank you, Stefan.
So I stopped sharing, and Frank, you have the floor.
Okay, just before we kick over to Frank, there were no questions came up in the chat. People were asking for a roadmap, more of a what's next. I think the 3-phase quad is something to look forward to. I've sold solar in many forms over many years.
Let me elaborate more, Sean, on the roadmap. So here we decided to show the 3-phase because so far we have not come up to Australia with a 3-phase. So the QT2 will definitely be a game changer into the commercial space. But we're also working on a YC600 under steroids. So we call it the DS3, D for duo, S for single phase, and 3 for third generation. For those who know AP system, we were present in Australia since 2012 with the YC500. Now we have the YC600, and the next will be the DS3. So 600, as the name suggests, is a 600 watt AC, and the DS3 will be a 900 watt AC. So that's something you can really go for the new modules that you can find now at Prosun on the market at 400 watt and 450. So that will be a no-brainer with the DS3. So the DS3 and the QT2 would be released first half of 2021. So we are very, very excited about these new products coming. I don't know if you have a question about the AC storage in the chat or.
Nothing's come up on the chat, but I think it is something we should touch on because it does. We are talking about comparing and contrasting with a certain North American brand we're not going to mention out loud. My experience with micros up until I encountered your product was something of a necessity. Only shade or technical imperatives would make you go with micros because the costs and the materials traditionally were a lot more than a string system. So a lot of people wouldn't go forward with it in a residential setting. With the APS guys, it's well, look, you got 4 trackers potentially. You're doing a 30 kilowatt system. You're buying 25 micros, not 100 micros. You know, you're saving so much material, so much labor. The comms are easy. You're not wiring in a chunky envoy for a residential situation. It's something as easy as plugging it into a GPO, turning on your app and kicking it off. There's a lot to like about the APS, and they're just some of the main reasons I'm excited to promote them and push them out into the market. You can't ask for more. Easy commissioning, materials and labor saving, and flexibility. Everything a micro should be, and up until now hasn't been. So APS have come to the party with, I think, a very unique point of difference, and I'm looking forward to seeing how well they'll go in the coming 12 months, especially with the new developments Stefan was outlining as on top. So a reminder, guys, questions in the chat box. If you don't put them in there, we don't know. Here we go. Are you able to open up the chat box where you are, Stefan? Can you see it? I think he's gone. He's frozen. Frank, are you there?
Yes. Let me have the question. The question, if upgrade, okay. We got if you upgrade.
Yeah, from Donald Yelland. Yeah. So
yeah. If we upgrade the CB, can we connect more YC600 per branch? That's this question, Frank, you were looking at.
Yeah. I think so, because of the size, the maximum quantity of the inverters per string circuit is limited.
What's CB?
Circuit breaker.
Circuit breaker. I'm not familiar with the code in Australia, so this would have to be looked at carefully. But if you increase the circuit breaker, you can increase the number of micros on paper. There might be a limitation for the current coming from the AC cable. So to be looked at. I wouldn't say yes or no, but it might be possible in certain configuration.
Okay. Just working through, can we use the Zigbee?
Home automation, can we access the Wi-Fi? So we have an API for Donald. We have an API, but the EMA, as you have seen, is very advanced. We monitor all the modules, everything. So the API is more high level. It only picked up the system performance, so energy production, but not module by module. And so far, we don't want to develop to be very transparent. We don't intend to develop an API to go module by module. So it go by system level. So you can have an API, and then you can definitely extract, let's say, the high-level performance of a system and transfer it to any home automation of your choice. We just provide we open up the bridge, but after that, you will have to have some kind of an IT expert to be able to finish up the bridge to your home automation.
Mm-hmm. Can we talk about off-grid?
Yeah, so the micro are really on-grid. So if the grid is shutting down, we don't have any backup solution. So maybe a good transition to the development of the AC storage solution. So we are a micro company, so our flagship products are the micros. We are looking at the trend of the market, and especially in Australia. So we are developing an AC storage solution. It will be modular by blocks of 2.5. And of course, the battery will come for a third party because we are not battery makers. But all the, let's say, I don't know how to say, the DC AC conversion will be done using our own micros, and the BMS will be done using the ECUC. So we have all the experience for these kind of things. So the priorities right now is on the launch of the DS3 and QT2. So the AC solution will come up a little bit later, end of 2021. But the micros are only on-grid, guys.
Understood. All right, gentlemen. One last chance questions, and then we'll kick it off with Frank.
Yeah. Can we export control the system remotely? Yes, we can. You can turn on, turn off at your leisure. I don't do it too often. On off. At sometimes the micros become a little bit lost, but you can do it remotely, and you can change the setup from the EMA portal.
I was speaking to Frank before the meeting started about the new South Australian requirements for grid-controlled inverters, turn off, and restrictions of export. APS, according to Frank, APS are in the process of being accredited and compatible. So watch the space. You will be able to use APS under South Australian regulations very soon.
We are already. There is a temporary listing until March 31st. So we are on the temporary list. So you can definitely use it right away.
Okay.
And the testing is finishing up, so I'm pretty confident that by the deadline of March 31st, all the testing will be done and stamped properly. But if you check this list on South Australia approved equipment, you can find the YC600 and QS1.
Okay. Another question there.
I see a question of send the API.
Yeah.
I'm happy to do that offline, Donald.
Donald, you'll see that I put my personal email address in there for two reasons, guys. I'm recording this webinar, so anyone who wants a recording of this webinar can get it. Also, any pricing or tech or other inquiries on APS, I'm happy to put you in direct contact with Frank if I can't help you myself directly, Stefan as well. So feel free to follow up at the end of the meeting. Okay, we'll have some more Q&A after Frank's done his shtick. So I'm going to shut up now and hand over to Frank.
Thanks, Sean. Thanks, Stefan. Sean, could you allow me? Okay, share my screen. Okay, capture my screen. Hello.
Yeah, I can see your screen.
Okay, that's good. Now I want to talk about the monitoring of the AP systems. Let's have a look at the web-based one first. So this is AP system web. On the right hand on the top, we have the EMA logged in. So click this one. So this is the login page. Input the username and password, and then can access the system and monitoring. So before going to the one demo systems, this is the YC600 demo system. So as you can see, a little bit slower. Yeah, yep. So as you can see, the first page is dashboard. So this is for the system information. We can see this curve represents the current power, and we can also see the today generation and other informations. And if we go to the module, we can see the performance of each panel. As you can see, this one represents one panel, and the panel difference could be because of the the shadings or the degrading things is different. And we can also apply the curve. As you can see, the system start very early, around 6 o'clock, yeah, and then the production increasing, and this could be like the cloudy day things affect the production of each one. Yeah, as I said, each one represents the power output of each panel, so all the panels can run independently. If we go to the report, we could have more information here. For example, this one is the today power curve, and if we click this one, they give us the hour generation. And if we click this one, this is daily. As you can see, this is the information, the generation of this system over the past 30 days. And we can even see the yearly lifetime generation, so back to the installation day. So if we go to the energy meter, we could have this one. Let's have look at what's it like yesterday. Yeah. So as you can see in this page, we have the consumption, production, and also we can know how much energy we absorb from the grid. And basically, if we go to the setting page, this is
Frank. Sorry to interrupt. So you guys here, Frank is showing really what a homeowner or end user can see. So it's very high level, very handy, very customer friendly. As an installer, so there is a 4 level on the EMA portal. There is the Super User Plus from the EMA team, R&D team in our R&D center. You have the local customer service with a super user, and you guys as installer will have access to more data. So if you see, for instance, on the module view, a panel which is not behaving properly, you can see at any time what is the AC voltage, DC, and you can quickly already narrow it down. If you see the DC at 12 volt, for instance, you can see, oh, my solar panel is dead. I need to change it. It's nothing to do with the micro. If you see you could see the AC voltage at 0, and I told you the micros are not off grid. So they will not work if AC voltage is 0, and then you can suggest the homeowner maybe the breaker are stripped during the night. So you will have more data behind those little black and orange square. So this is just an end user view. So we don't want to give end user all the access to the current voltage, everything. Otherwise, it will be too many phone calls, too many questions. So we need to keep it simple.
Thanks, Stephen. Yeah, as Stephen said, what I'm showing is only for the system owner. So this is a basic level for them. And let's go back. Yeah. Okay, so yes, the system owner can access with the logged in, and then they can have the panel level informations and other information. They could also download the app to their smartphone, and monitor the systems every day. And we also provide another level monitoring to the installer, and you guys can manage all the system installed. So I'm going to show you what it's like. This is one of my master account. So this is when we register the master account, the installer account for you guys. You will, when you log in, you will have a list of the system installed, and if you click to each one, you can manage. You can manage the the system. We back to the answer. Back to the question Ryan asked, if we can remote control the system. Yes, we can. An installer can access the installer account and make some change to the system, the end customer system. So, and also you have more functionalities with the installer account. You could also use the installer account to register the new system install and provide the access amidst the login to the end customer. If you want to make some change, you can use the installer to do it. So basically, for AP systems, we provide two-level monitoring. One is basic one for the system owner, advanced one for the installer, and the installer can manage all the system installed, but your end customer could only see their own system. They cannot see others. You can see all the system installed. So basically, this is how the monitoring works for AP system solution. Yeah, I think that's all about my presentation today. It's quite short.
That's it, mate. Speed run. Fantastic. Okay. Again, guys, thank you so much for attending a little webinar. I'm going to open the floor.
I see a question, Sean, from Donald about your installer account.
Yes.
Login. Where did you? Maybe we can discuss that offline. But where did you send your request? Maybe you use a web form or you send it to our tech support in Australia. Feel free to touch base with me offline and I figure it out.
Yeah, I think for troubleshooting and tech stuff, yeah, that's probably best to take it offline.
Yeah.
If anybody has any product questions, now's the time to ask. So just drop it in chat there. Okay, what have we got here? Show us the detailed voltage web form. Okay.
Frank, do you have an installer account or not?
Can you give them a look at the web form?
I can try to do it live, guys, to show you the web form. Give me a second to share my screen then.
Okay. Yep.
Let me prepare the thing. Give me a second.
No problem. While you're doing that, Stefan, anybody else have any questions or concerns? I mean, no joke, guys. I've not been a huge fan of micros for many years, considering the only choice was a certain North American brand. The APS is it's very exciting. It's something I'm looking forward to seeing the market take up and embrace. I think it will it'll do so quite briskly. So again, I'm recording this webinar, so anyone wants your copy, just ask me. My email address is in the chat. It's Sean, SEAN, @prosunsolar.com.au. Certainly feel free to reach out and make contact, and I can furbish you with that information.
Stay with me, guys. I'm trying to find an install where I can show you a few things with zero export. So I'm trying to find an install where the zero export is turned on. So give me a second. That might be this one. 2-1.
Okay. Also, $100 gift vouchers will be sent out to all registered participants. That'll come in the next week or so in the email. Look forward to seeing you on that one. All right, Stefan's ready.
I'm ready. Thanks for your patience.
Share on.
Yeah. All right. I'm loading it, and then I will share my screen. Sorry about that. All right. Let me try to go back to Zoom and share my screen. Actually, can you see my screen, guys?
Yes.
So here I'm a super user, so I have all the function you can imagine. You guys, as an installer, would be where you will have less functions, so you can recognize the dashboard module view that Frank was showing for end user, and here you can see the performance of every day. So you know, sometimes it's not a nice bell curve because it was 7th of October yesterday, and it was a shitty day in France. So yeah, okay, there is no secret, you know. So it's really real data, and if you on an installer account, you have a detail function here. You press on it, and here you can really see everything. And I hope it will come to life. All right, so you can really see everything when we were saying. So you have the ECU ID, the inverter ID, and you have this is YC600. So you have two input, channel 1, channel 2. So you have on the DC side, you can see the voltage on the panel. You can see the current in blue. You can see the power. So the EMA guys report the power on the DC side. You can check the input number 2, which is also on the DC side, and the output, that's the AC side. So here you can see the trunk cable is nicely connected to the grid because in France it's a 230 volt grid, so it's very nice. But okay, why is it fluctuating back and forth? Because this guy maybe has the zero export turn on. So let me show you the curve. Let's go for this full day. So as you can see, you have the production solar and the what's the load in the house, and you can see that we can see the curve. So there is a zero export. So basically, when you never inject. It's not a good example yesterday. Let's try. But this guy has a zero export, so you can turn in on and off from the remote control as an installer. You have the meter zero export here. You will have this function as an installer, and if you forgot to do it on site, or I don't know, the regulation change in Australia and suddenly you can export into the grid. So meter display, it's when you have the CTs, you can on off. I see the curve, I don't see them. Zero export, I don't want it anymore, I close it. And you can do it also, the zero export, in using QS. Allocate QS1 YC600 to phase 1, 2, 3. You lost me?
Just for a second, you're back down.
Okay. So you have everything as an installer. You have the ECU data, the inverter data. You can check the grid profile. You can check the parameter. You can turn on, turn off remotely some micros. You won't have access to the alarm information. This is only for tech support. Just for your information, guys, the micro goes into alarm, and then you can see here it's 8 o'clock in the morning in France today, 9 of October, and yeah, the sun starts shining, and the micro start producing very little, because it's fall here, so it's not great. So you won't have the AC alarms. Just for your info, a micros goes into alarm from time to time during the day. It's there's nothing alarming. It's just a protection mode. So it's if you have a surge in the grid, the micro will shut down, you know, and when the surge is gone, it will take off again, and stuff like that. You have an overall button, diagnose. This one you will have it, and so you have 4 traffic light: green, everything is okay; yellow, a micro or more are not behaving as they should; red, the ECU is not connected to the internet. Sometimes it happens. The homeowner change internet supplier, change the router. Or gray, it's at the beginning when there is no data exchange between the ECU and the cloud. And here you can find all the info of your homeowner. I'm not going to press it for privacy, but you have the name and the address and the type of module and the type of micro and his login and password and all the RGPD or GDPR in English paperwork. So again, this is a super user.
Yeah, there goes your mic again. And he's still out.
Can you hear me?
Yeah, you're back now.
Okay, so you will have less function on the remote control, but enough to do, let's say, troubleshooting level 1. And if you guys are lost, please do not run to the site right away. Go on the roof to check. Call the hotline for the tech support in Sydney. Drop us an email at the tech support. We can definitely see all the things you see, and as I was saying in the presentation, we can push software firmware upgrade. We can resuscitate the micro remotely. So before you guys go on site with a toolbox, please give us a call, open a ticket with us. We can check remotely, and if you really cannot fix it, we will tell you it's a RMA, it's faulty, sorry, you have to replace it. But at least when you go on site, you know that you go for replacing a micro and not for nothing. So again, the advantage of the remote monitoring: open a ticket with a local tech support, give us 24, 48 hours to look at it, try to fix it. 80% of the time we can fix it remotely, pushing some commands through the ECU. And if we cannot, yeah, it's a RMA. It happens. You know, I'm not going to tell you that it never happens. I would be lying and would not believe me. But again, that's the key message. You know, don't run to the site as soon as the homeowner tells you, hey, my micro is not performing. Check the EMA. Maybe it's a basic things. Breaker has tripped. The module is dead. Or open a ticket with the tech support, and we can look at it and try to resuscitate the micro from a distance.
Awesome. That sounds like a really smart bit of servicing there. The field programmable gate array, programmable logic, or CPLDs, they used to be called. Is it, like you say, it's the technology that goes onto the PCB is actually quite cutting edge. A piece of programmable logic is basically whatever you tell it to be at any time. It's a lot of plasticity in it. So, like you say, pushing updates and directions down the internet to the device, remote resuscitation. It's just really amazing the level of technology you guys put into the construction of your micros. So, hats off to you.
And if you, there was a question about where is the web form. So you need to go to AP System website in Australia, and in the menu you have resources menu, and you have a registration, EMA registration, and then you have a web form. You enter the name of the company, contact name, address, maybe some VAT numbers or whatever is required in Australia. And then we are able to, from that, to create your installer account, give you your credential within 24 to 48 hours working days.
Okay. Another question from Donald regarding external battery BMUs, etc. I think we might make that our last question for the day.
If you use external battery BMU and we lose grid power with the BMU, allows the system to continue operating. No. The micros are really on grid. So I don't think a BMU can. We cannot do frequency shift with our micros, so to trick them. So it will be really they will be off. So then we will have to use a battery backup to power up the key appliances in the house.
Additional questions, you can certainly submit them. Obviously, Donald, you have Frank's direct contact details now. I've copied you on an email I've sent you to Frank regarding another question of yours. You have my email address. I'm happy to pass all questions on or have a go at assisting you directly. So I'd like to thank everybody for attending today. I think we all learned a lot and picked up a bit. So without further ado, I'll just leave it to you, Stefan and Frank, for final remarks, and then I'll end the meeting.
Well, I leave the last word to Frank, but thank you guys for attending. It was really fun for me, even though early in the morning. And I hope you enjoy the show. And Sean speak highly of APS System. We're proud to have Prosun as a partner. So feel free to try it out and be careful. You may get addicted. It's really plug and play, easy to use. So we'll be happy to have you part of our installer base in Australia.
That's awesome. Yes, I think, guys, you just got to get your hands on it, and you'll be surprised how much it's a revelation. You'll never use that stuff that Florian sells again. I mean, you know what I mean. That North American brand will be nothing once you try the APS. Frank, over to you, and then we'll sign off for the weekend.
Yes, thanks, Sean. Thanks, Stefan. Give the wonderful presentation, and thank you guys joining the training today. So if you guys have any further questions, can send to Sean or can contact me directly. And we also have the support team based in Sydney. Mm-hmm. So we are happy to help you guys. It doesn't matter it's on site or or in the designing stage of the system. So if you have any questions, feel free to contact us. So thank you guys today.
Thanks, guys. Thanks a lot.
Thank you. Bye-bye. Have a good weekend in Australia.
You too, mate. Okay.
Bye-bye.
Bye. Bye, Stefan.
Bye-bye. Take care.
Bye. Okay, Donald, Rafiq, and Sean, I'll hopefully talk to you guys at some stage in the future. Frank, have a good weekend. And he's gone. Okay, see you later, guys. Thanks for coming. You're welcome, Donald. Cheers, mate.